Welcome to assignment 7 for week 2. Don't forget, we've got a test this week. You've got 2 assignments due this week, a discussion board due, and a test review that's going to help you a lot on your test. Not only that, we've got office hours on Tuesdays and Thursdays and by appointment if you need to set up a Zoom so we could talk in person. Or in person on Fridays if you set that up with us as well. We're happy to meet there. So let's get started. Assignment 7 shouldn't be that crazy. It should be pretty similar to the one before. It's kind of like a little bit of review. Just a lot of factoring with some special cases that you'll have to see play out. So I'm actually going to do a somewhat harder one as our example because I think you should be able to get through the first ones pretty easily. So here we go. Let's get started. So we look at this problem and say, ooh, it's got 2 variables. It's got a lot of factoring. It's got some numbers that don't really go well together. A 1, an invisible 1, right? A 2 or a -2 and a -35. None of those play nice together. So the number factoring might not be the hard part. What looks like the hard part's going to be is probably how the x and the y relate to each other and how we can factor even though it looks a little messy. So we know that factoring always ends up yielding us these 2 brackets, right? These 2 factored terms, maybe 3, maybe 4, but in this case, we've got a squared. It's just going to yield us 2 terms. So we got to say, okay, we know what 2 terms can multiply to get us that first term, don't we? If we're doing first, outer, inner, last, our brains know the first 2 multiplications because what times what equals x? Well, x times x, right? That's pretty awesome. That helps us a lot. But then our brains have to say, oh no, what things can multiply to get me that last term? And the tricky thing is now there's a y attached to it. But just like before, we're going to do this factor tree, and we're going to just list out all the things that multiply to get me that last term. So if we start at the very, very basic, we've got -35 and 1, right? And then 2, it's odd, so no. 3, no. 4, no. 5, yes, it looks like -7 and 5. Okay, 6, no. 7, we're back to 7 already? So those are the only 2 terms, I guess. Because then we get back to 7 and we get 7 comma -5. And then we get all the way back to 35 and -1. If I missed any, let me know. But I actually already see the one that's going to work in my brain. But we got to hold up. So this is where it gets a little different than what we did yesterday. Is that those numbers alone don't multiply to get us -35y squared. These 2 numbers just multiply to get us -35. So what things do we need to add on to get us that y squared? Well, I think it's pretty obvious what we end up with, but let's take it slow and find out. If we tack a y onto each one of these, right? Now, does that get us what we're looking for? Yes. But does that help us with our middle term? I don't know. Let's find out. If we multiply some number with y times x, doesn't it make sense that we'd get some number with x and y? Well, yeah, and then at the very end, we're going to check it just to make sure. So let's see what happens. We're looking for the 2 numbers that add up to give us that middle term. Remember, we want them to multiply to give us the last term, add to give us the middle term. So what 2 numbers here add up to give us -2? Not 35 and 1, not 7 and 5, because that would be a +2. So these 2 are going to add up to give us a -2, right? All right, well, let's check it out and see what happens. So let's throw in a -7y. And a +5y. And just guess. So we're just saying, hey, these numbers we know multiply to give us our last term. We know the first 2 numbers multiply to give us our first term. And let's just see what happens when we play it out. So what we're going to do is we're going to FOIL. We're going to do first, outer, inner, last. Here's a little good review if you don't want to go back and watch that video of how to FOIL. So I'm going to do the first one in blue. X times x. What's x times x? X squared. Green. Outer, that's the outer 2, that's the sandwich bread. That's the bread of the sandwich. So we're going to take our bread of the sandwich, which is the green and the green. Whoops, I don't know why I went way up there. It's down here. X and 5y. So what's x times 5y? Probably 5xy, right? Okay, now let's do purple. Inner, that's the inside of the sandwich. Boom, boom, boom. And we got -7xy. That's kind of cool. And then last, what color haven't I used yet? That's all the colors. Okay, we'll just do black. Last, the last terms, the terms that come last in each parenthesis. So we've got -7 and 5y. So those 2 multiply to get us -7 times 5 is -35. y times y is y squared. And if we add all of these terms up, so we add the x squared, and then we add the negative 7xy, and then we add the negative 35y squared, we should get x squared plus 5xy minus 7xy minus 35y squared. And then we ask ourselves, can we combine like terms? Like terms, we've said this before, they have to have the exact same variables and the exact same exponents. If it's one or the other, it's not good. They have to both match perfectly. Well, right here, I see this xy, right? That's a variable. I see another xy. Those two are going to combine, and nothing else will. Everything else kind of looks, this x does not look like this y squared, does not look like that xy. So we end up with x squared by itself. If you have 5 cookies and I steal 7 cookies, you're left with negative 2 cookies. So that's negative 2 xy's. And then negative 35y squared. That was my check step. That was to check it. Did we end up with what we wanted? X squared minus 2xy. Perfect. That's awesome. So we used the same principles. We just added an extra variable and it looked a little different. All right. Let's do one more. And then the rest of it's all yours. We're going to do 13 now. This one looks a little different too because we're missing that middle term. It's a perfect, so if you don't want to memorize all of the perfect squares, which you know 9 is a perfect square, 3 times 3 is 9, so we're probably going to play off of that. But if you don't want to memorize all those things, what you can do is you can say, well, I want to rewrite this as a perfect, or as a fully factorable term. So watch this, x squared, that stays the same. What's usually in the middle there? Well, usually there's a 0, or usually there's an x term, right? Well, 0 times anything is 0 and it just goes away, so let's just pretend like it's there and leave that 9 alone. Those two things are the same thing. Now, you don't have to do this. You can factor out the perfect square if you read the book and you process that. But if you want the proof and you want to see why, you can just factor out 2 perfect squares, one positive, one negative. Here's the proof. So then we break down that 9 into the factorable terms. We've got 9 and 1, 1 and 9, a positive and a negative, right? What else we got? 3 and 3. 3 and 3, positive, which I guess doesn't matter because they're the same number. And which terms of those 3 terms add up to give us that middle term or that middle 0? Well, only one of those is going to work, right? The 9s don't work. 3, positive 3 plus negative 3 gives us 0. And that works out perfect. So we're left with our first terms, x plus 3 and x minus 3. And you could do your FOIL or your box method to check if you wanted to. All right. Sounds good? Don't forget, watch these 2 videos, finish these 2 assignments, check out that test review, get ready for your test that's coming up this week. We want you to do as well as you can, so come to office hours, talk to us, figure out what you don't know, what you do know, and what you need to work on. All right, we'll see you soon.